Imagine a vast expanse, a cosmic wilderness dense with countless galaxies, each unique, filled with stars, gas, dust, and dark matter, all bound together and dancing around a common center thanks to the unyielding force of gravity. The Milky Way, our own galactic home, is just one among multitudes. Scientists estimate there could be up to 2 trillion galaxies in the universe. Their sizes and shapes as diverse as the stars within them. From the faint, rounded shape of elliptical galaxies devoid of gas and dust to the luminous, disc-shaped spiral galaxies enriched with hot gas, dust, and bright stars swirling in their spiral arms. And then, there are those that defy regular classification, the irregular galaxies, small, faint, featuring large clouds of gas and dust, and a mix of old and new stars. But, the most fascinating part about galaxies is not just their abundance or diversity, it's something else. It's, well, be patient, all in good time. You'll find out soon enough. What's up, my amazing and curious folks? Ready to unravel mysteries together? I'm your host, Caesar, and with me is the ever-insightful Sonia, ready to dive into the cosmic depths of today's topic. Remember, if you're as captivated by curiosities as we are, make sure to subscribe to our channel and hit that bell icon so you don't miss out on our daily deep dives. Isn't that right, Sonia?
Absolutely, Caesar. Hi everyone. Buckle up as we're about to take you on a journey across the universe. Trust me, you don't want to miss this.
When you gaze up at the night sky, you're observing just a tiny fraction of the cosmic spectacle. The faint band of stars that spreads across the sky, especially visible during summer nights, is part of our home galaxy, the Milky Way. It's home to about 200 billion stars, including our Sun. But remember, the Milky Way is just one galaxy amidst a cosmic sea of galaxies.
That's amazing. But how many galaxies are actually out there in the universe?
That's a great question. Estimating the number of galaxies is quite challenging. It involves deeply observing the universe with powerful telescopes and extrapolating those findings to the whole universe. Based on such observations, scientists estimate there could be as many as 2 trillion galaxies in the universe.
Wow, 2 trillion. That's kind of hard to wrap my head around. Can you give me an example to help visualize that?
Imagine if each galaxy were a grain of sand. 2 trillion grains of sand would be enough to fill over 60 large-sized dump trucks.
That's a lot of sand, or rather, galaxies. So, what types of galaxies are out there?
Galaxies come in all sorts of shapes and sizes. They can be roughly classified into 3 main types: elliptical, spiral, and irregular. The formation and evolution of these diverse shapes remain a mystery. We also know galaxies are far away from each other and are constantly moving away from one another as our universe expands.
Wait, galaxies are moving away from each other?
Yes, that's right. It's like the universe is stretching, causing galaxies to drift apart.
That's fascinating. And what about these active galaxies you mentioned?
Active galaxies are truly interesting. They emit huge amounts of energy in the form of radiation. These galaxies may have exotic structures, like supermassive black holes at their centers, making them an important area of astronomical research.
A supermassive black hole? That's something I'd rather not run into.
Haha, indeed. The universe is full of wonders and dangers. But don't worry, we're safe here on our little blue planet, and there's still so much more to explore and understand about these cosmic wonders. Interestingly, when scientists first estimated the number of galaxies in the early 2000s, they proposed a number of around 200 billion. However, a more recent survey based on data from the Hubble Space Telescope suggests the number could be at least 10 times that.
That's a huge jump in estimates.
Absolutely. It goes to show how our understanding of the universe continues to evolve as technology advances. Now, let's talk about the types of galaxies. They vary greatly in size and shape, ranging from 10 million to 10 trillion stars.
10 trillion stars in one galaxy? That's mind-boggling.
Indeed, it's hard to comprehend the immense scale of the universe. One notable galaxy classification was made by Edwin Hubble in 1936, known as the Hubble sequence.
Hubble sequence, that's named after the same Hubble that the Space Telescope is named after, right?
Precisely. The first type in the sequence is the elliptical galaxy. They are faint and rounded, lacking gas, dust, and visible bright stars or spiral patterns. They make up about 60% of the galaxies in the universe.
So, these are the most common type of galaxies then?
Yes, but they vary greatly in size. Some are tiny, about 1% the diameter of the Milky Way, while others are about 5 times larger.
Let's move on to the next type.
Sure. The next type is the spiral galaxy, which is what our Milky Way is. These galaxies are distinctly disk-shaped, with hot gas, dust, and bright stars in the spiral arms. They make up most of the visible galaxies.
And the third type?
The third type is the irregular galaxy. They are faint and lack spiral arms or bright centers but contain large clouds of gas and dust.
So, each galaxy type is unique in its own way. This is also fascinating.
Let's dive deeper into the structure of a galaxy. If we take spiral galaxies as an example, they have some of the most complex structures.
Can you break down these structures for me, Caesar?
Indeed. In a spiral galaxy like the Milky Way, most of the over 200 billion stars are located in the galactic disk.
The galactic disk? What's that?
It's a region that includes the nucleus, which is the center of the disk. Around the nucleus, there is a bulge. Then, there are spiral arms that extend outward from the center. Our solar system is located in one of these spiral arms.
Oh, we're part of a spiral arm. What about these globular clusters you mentioned?
Good question. There are a few hundred globular clusters scattered above and below the disk. The stars in these clusters are much older than those in the galactic disk.
And what's this halo you're talking about?
The halo is a large, dim region that surrounds the entire galaxy. It's made up of hot gas and possibly dark matter. All of these components are held together by gravity.
So gravity is the glue that holds everything together?
Exactly. Interestingly, most of the galaxy's mass isn't in the galactic disk or near the center, as one might expect. It's primarily in the outer portions of the galaxy, like the halo.
That's intriguing. And what about the history of our understanding of galaxies?
It's a rich history. The term galaxy actually comes from the Greeks who described the Milky Way as galaxies kuklos, meaning milky circle. When Galileo first used a telescope to observe the Milky Way, he determined it was made up of numerous stars. But back in the 18th century, it wasn't clear to astronomers that the Milky Way was a galaxy and not just a distribution of stars.
It's amazing how far we've come in our understanding of the universe. Thanks for the enlightening discussion, Caesar.
As our understanding of the Milky Way evolved, astronomers like Charles Messier took steps to classify nebulae throughout the sky, identifying several as spiral nebulae.
I can imagine there was a lot of excitement about these discoveries.
Definitely. And the advancements didn't stop there. In the early 20th century, Harlow Shapley discovered that the center of the Milky Way was a bulge, not flat as previously thought, and was approximately 28,000 light-years from Earth.
That's quite a long way away.
Indeed, it's a vast distance. Later, an astronomer by the name of Edwin Hubble settled a major debate about the nature of these spiral nebulae.
Oh, I'm curious to hear what that debate was about.
Well, some astronomers believed that these spiral nebulae were separate island universes or galaxies. However, others argued that they were merely part of the Milky Way.
So what did Hubble find?
Using a large telescope in California, Hubble identified stars in these nebulae that changed their brightness regularly. He used this information to measure their distances and concluded that they were far beyond the known limits of the Milky Way.
So, they were indeed other galaxies.
Exactly. And did you know that the closest galaxy to us, the Andromeda Galaxy, is 2.2 million light-years away?
That's unimaginable.
And that's just the beginning. The farthest visible galaxies are about 10 billion light-years away.
10 billion light-years. The universe really is incredibly vast.
The formation of galaxies is a complex topic with many theories. One idea is that they formed from collapsing gas and dust clouds shortly after the Big Bang, about 14 billion years ago.
So, even galaxies have a birth story. Do all galaxies form the same way?
It's believed that interactions between galaxies, like collisions, played an important role in their evolution. But there could be differences in how they form. For instance, those protogalactic clouds with more angular momentum or degree of spin might have spun faster to form spiral disks. Slower spinning clouds might have formed elliptical galaxies.
That makes a lot of sense. Do we have any examples of this?
Well, think of it like spinning pizza dough. If you spin it fast, it forms a flat, wide, disc-like shape, much like a spiral galaxy. If you spin it slowly, it remains more clump-like and elliptical.
That's an interesting way to put it. But why do some galaxies have disks and some don't?
Cooling seems to play a significant role in this. High-density protogalactic clouds cooled faster, using up all the gas and dust in forming stars. That left none for making a galactic disk, which is why elliptical galaxies lack disks. On the other hand, slower cooling, low-density protogalactic clouds retain some gas and dust for disk formation, as in spiral galaxies.
Fascinating. This is like a cosmic recipe for creating galaxies.
Yes, and keep in mind that we're still trying to unravel these cosmic recipes. The universe keeps us on our toes. Now let's delve into an exciting aspect of galaxies: collisions. Despite the vast distances between galaxies, they can and do collide. However, it's not like a car crash. The stars within don't smash into each other due to the immense space between them.
Wait, so galaxies can collide and not be destroyed?
Exactly. But these collisions can distort a galaxy's shape. And fascinatingly, it seems that encounters between spiral galaxies can result in elliptical ones.
So, are these collisions good or bad for the galaxies involved?
Well, they can actually stimulate waves of new star formation, trigger supernovae, and even lead to the creation of black holes or supermassive black holes.
Well, it seems like galaxies are always in motion and evolving.
Absolutely, and they don't exist randomly either. Galaxies are found in clusters, bound together by gravity. For instance, the Milky Way and the Andromeda Galaxy are part of a group of about 50 galaxies called the Local Group.
That's fascinating. But what about the space between these galaxies?
That's the intergalactic medium, which is not entirely empty. Although its exact nature is still being researched, it's believed to contain a relatively low density of gas with varying temperatures.
So, there's a lot more happening in our universe than just stars twinkling in the night sky.
Indeed, every twinkle tells a cosmic tale. Now, let's discuss Hubble's law. This law came from Edwin Hubble's observations of galactic distances and the spectra of light that galaxies emit. He noticed that all galaxies seem to be moving away from us.
So, does Hubble's law imply that we are at the center of the universe?
Not exactly, it's more about the universe expanding. The faster a galaxy is moving away from us, the farther away it is. This relationship is expressed mathematically in Hubble's law as the velocity of recession equals the galactic distance times a constant, known as the Hubble constant.
That's a little hard to grasp. Can you break it down a bit more?
Sure. Think of it like a balloon being inflated. The galaxies are like dots on the balloon. As the balloon inflates, all the dots move away from each other, and the farther apart the dots are, the faster they move away from each other.
That makes a lot of sense. But how do we know a galaxy is moving away from us?
That's due to the Doppler effect. Similar to how a siren's pitch changes as it moves past us, the movement of stars affects the wavelengths of light we receive from them. If the light is shifted to the red end of the spectrum, the star is moving away. If it's shifted to the blue end, the star is moving towards us.
There's so much to galaxies. But what about those galaxies you mentioned that emit such large amounts of energy?
Ah, you're referring to active galaxies. They're a small percentage of all galaxies, but they emit intense light from their nuclei across multiple wavelengths. This is still a field of active research, and scientists think black holes might be involved in these galaxies' high energy emission.
Black holes in galaxies? That's absolutely mind-blowing.
Yes, the universe is full of wonders waiting to be explored. Continuing from where we left off, the most accepted hypothesis is that active galaxies have massive or supermassive black holes at their center. Surrounding the black hole is a spinning disk of gas, which, as it falls into the black hole, heats up and is accelerated outward.
So, these active galaxies are like cosmic lighthouses, emitting intense light from their cores?
Exactly. And there are different types of active galaxies. For instance, Seyfert galaxies, which have cores of hot, ionized gas, change brightness every few weeks.
Changing brightness? How can that be?
This is due to the objects in the center being relatively small and the velocities at the center being about 30 times greater than those of normal galaxies.
That's fascinating. What other types of active galaxies are there?
There are also radio galaxies, which are elliptical and emit jets of high-velocity gas from their nuclei that interact with magnetic fields and emit radio signals. Then there are quasars, the most energetic objects in the universe, believed to be originating from the cores of distant galaxies.
That's amazing. And all this is happening millions of light years away from us.
Yes, and there's more. Blazars are another type of active galaxy where we see the jet emanating from the galaxy head-on. And lastly, there are starburst galaxies, which have a high rate of new star formation, producing more than 100 stars a year.
So, galaxies are not just collections of stars, but they're dynamic, evolving, and often intensely active entities. The universe is even more fascinating than I imagined.
It certainly is. Every galaxy has its own story to tell. Starburst galaxies, which we mentioned earlier, emit intense light from a small area of newly formed stars and supernovae. They're thought to represent a short phase in a galaxy's evolution, possibly a stage before becoming an active galaxy.
So, galaxies can morph from one type to another over time?
That seems to be the case, yes. Now, would you like to guess how many galaxies there are in the universe?
Oh, I wouldn't dare. The universe is vast beyond comprehension.
There could be as many as 2 trillion galaxies in the universe.
That's an unimaginable number. And all of them are teeming with stars, dust, gas, and dark matter, right?
Yes, they're all bound by gravity and orbit a common center. Each galaxy is like an island universe unto itself.
And we reside in just one of these galaxies, the Milky Way.
Correct. Speaking of which, the Milky Way has about 200 billion stars. But galaxies can vary greatly, they could have as few as 10 million stars or as many as 10 trillion.
And these galaxies come in different shapes too, don't they?
Yes, Edwin Hubble classified galaxy shapes into 3 types: elliptical, spiral, and irregular. Our Milky Way, for instance, is a spiral galaxy.
The universe is truly a treasure trove of wonders.
Indeed it is. And we've only just scratched the surface. There's still so much more to explore and learn about galaxies and the universe. If you've ever wondered about the hidden lives of galaxies, you're not alone. Scientists spend their lives probing these mysteries. They use everything from telescopes that capture UV light to mapping the universe to understand these celestial entities.
It must be exciting to discover and understand more about galaxies every day.
Indeed, it is. For example, a resource called the Galaxy Evolution Explorer, or GALEX, helps researchers dive into these celestial mysteries. Even the NASA's Imagine the Universe program provides valuable insights about active galaxies and quasars.
So, with more exploration and technology, we're able to better understand these island universes.
Exactly. And remember, there's a vast universe out there filled with galaxies in different shapes, sizes, and stages of evolution. From starburst galaxies to active galaxies, each one has a unique story to tell.
And we're just tiny specks in the grand scheme of it all.
That's right. But even as small as we are, we're part of this incredible universe, and we have the privilege to explore and understand it. There's always more to learn, and each discovery brings us closer to understanding our place in the cosmos. We've embarked on a fascinating journey through the cosmos today, unraveling the mysteries of galaxies. From the lively spirals of the Milky Way to the enigmatic active galaxies, we've seen that each galaxy holds a unique story of creation, growth, and evolution.
It's mind-boggling to think about it. We're just tiny specks in a universe full of 2 trillion galaxies. But even as specks, we're capable of uncovering these cosmic wonders.
Absolutely. And remember, each galaxy is like a book in the library of the universe. There's a never-ending supply of stories waiting to be read.
For sure. And didn't our journey make you feel like a cosmic librarian today?
It sure did. And remember, folks, the universe is always expanding, which means our cosmic library is always growing.
That's our cue, listeners. If you had as much fun exploring the cosmos with us as we did, don't forget to blast that like button. Please share your thoughts in the comments section, and share this episode with your friends or anyone who loves a good cosmic tale.
Thanks for joining us on this intergalactic journey. Until the next time, keep looking up and wondering.
Goodbye, everybody. Stay curious, stay wonderful.
This captivating journey through galaxies was inspired by the article Just How Many Galaxies Are in the Universe, written by Craig Freudenrich. It was published on HowStuffWorks site on November 8, 2023. The full URL is in the video description if you wish to further explore the cosmos. Now, I'm off.